Okie dokie, friends. So on today's show, we get to talk about this thing called the chain rule. And we get to talk about this thing called the chain rule for finding derivatives because at some point in the development of the calculus, somebody came across a problem like this. Y equals x squared plus 1 to the 8th power. And that person wanted to find y prime. And the only way that we would know of to do this problem would be to expand this out, 8th power, binomial expansion theorem, what a mess, nobody knows it, just a mess. And so the thought occurred to me, what if instead of x squared plus 1 to the 8th power, what if the problem was chicken nugget to the 8th power? If the problem were chicken nugget to the 8th power, could you find the derivative? And the answer is, sure you could. You would have 8 times chicken nugget to the 7th power. The chain rule says you can do that, but you have to multiply by the derivative of the chicken nugget at the end. So the chain rule goes something like this. If y is a function of u, that does not say fu, that says that y is a function of u, and u is some other function of x, then the derivative of y with respect to x is the derivative of y as if u were the variable, as if u was the variable, as if u were the variable, times the derivative of u with respect to x. The other way that this is sometimes said is that if we have a composition of functions, f of g, and we take its derivative with respect to x, we take f prime and evaluate it at g of x. So f prime, but with g of x subbed in, times g prime of x. And there are reasons why this works, and they're beyond the scope of our course, and you've got to trust me that it comes from somewhere. I've seen it come from that somewhere. So back to our situation. Can we treat this as if it were y equals chicken nugget to the 8th power? Well, sure. If we're decomposing, we would say that y is, mathematicians find it hard to draw chicken nuggets. I'll try. Chicken nugget to the 8th power, where chicken nugget is x squared plus 1. Now, mathematicians don't generally write chicken nugget. They generally write u. So, well, maybe we'll try that. Y is u to the 8th, where u is x squared plus 1. The derivative of y with respect to u is just the derivative of this thing by the power rule. And the derivative of u with respect to x is just the derivative of this thing by the power rule. And so when I want the derivative of y with respect to x, I just multiply this by that. 8u to the 7th times 2x. If I see that this thing is chicken nugget to the 8th power, the derivative is 8 chicken nugget to the 7th times the derivative of the inside. And then we do not, under any circumstances, try to simplify that at all ever because, well, that's a mess. So we don't do that. Well, let's see just a second example here. Let's find y prime if y is the sine of x squared minus 4. Well, this is a composition of functions. We have the sine of something. That something is our u function. We have the sine of something where that something is differentiable. So when I want the derivative of y with respect to u, Well, that's just cosine u. The derivative of the sine function is the cosine function. And then the derivative of u with respect to x, well, that's power rule. Got it. So when I want the derivative of y with respect to x, I multiply this by this. I get the cosine of u. Wait a minute, you didn't write cosine. Oh, you did write cosine u. Oh, okay. Times du dx. So if I see the sine of chicken nugget, the derivative of sine chicken nugget is cosine chicken nugget times the derivative of the nugget. Okay? So what about find y prime if y is the square root of sine squared x plus 4? And you're thinking, what in the world? Because here we've got a square root and there's something inside, so I'm pretty sure that y is the square root of u. Okay, that I can do. I can handle this part. But the u, well, that's got like a thing that's squared, but that thing isn't x, like it's got a weird squared thing. So u is really some other guy squared plus 4, where that other guy is sine x. And so I find the derivative of u with respect to v, and I find the derivative of v with respect to x, and I say when I want the derivative of y with respect to x, I multiply this by this by this. 1/2 u to the negative 1/2 times 2v times cosine x. Now some people are going to simplify that, and that's fine. But that's the way we decompose these functions. So I'm going to show you a couple that you can do on your own. This is the on your own section. I'm looking to see if you can differentiate the following. Y equals 4 minus 3x to the 9th, and y equals cosine to the 4th power of 3t squared plus 1. So hit the pause button, try to decompose these things, see if you can do it. Okay, so my thought here is that this is something to the 9th, and the derivative of something to the 9th is 9 somethings to the 8th power, and the price I pay for seeing the problem in that simple a fashion is that I have to multiply by the derivative of the inside. Some people are going to simplify this like so, and those are fine people also, although you could have left it in this form. Over on the other side, at my most basic level, I have something to the 4th power. And the derivative of something to the 4th power is 4 times that thing to the 3rd power. And then I look inside, and I've got cosine of blah-bitty-blah. So the derivative of cosine of blah-bitty-blah is negative sine of blah-bitty-blah. And then I take the derivative of that. So I hope you were able to come up with those things. I've got one more before our time is done. Let's let f and g be differentiable such that, and I'll just give you some values that might be useful to you. I'll give you information about f, g, f prime, and g prime. And I'm just making up numbers because you're not going to use all of these anyway. But they're all there. I want to find the derivative of f of g at 2. I want to find the derivative of f of g at 2. And the way we find the derivative of f of g at 2, go back to the first slide. Go back to the first slide. Go back to the first slide. On the first slide, we find f prime of g times g prime. F prime of g times g prime. So now back to our slide. We're going to find f prime at g of 2 times g prime of 2. And so what is that? That's f prime of 3 times g prime of 2, and that's negative 5 times negative 2 is positive 10. That is the kind of thing you should know how to do. Okay, that is a very brief look at the chain rule. I will absolutely have more to say when we get together in class about that, but that gives you some framework for the discussion, and I'll be glad to do more when we get together. Okay, thanks everybody.